So this is the first of several sets of problems where you're going to be drawing Lewis structures and then answering questions about them. So in my answers here, I've done exactly what I'm going to tell you not to do, which is just look at the drawing. It's very important, and maybe you don't need to do this for everyone throughout the whole process, but it's very important that you go through the steps. Count your electrons, 4 for each silicon, 7 for each chlorine. Add all of that up. So 7 times 4 is 28, plus 4 is 32. You start with the single bonds connecting everything. You fill your outer atoms with their 6 more dots, and then you see how many of you have used. Our goal is to give 8 to every element, including our central element, and to use exactly the right number of electrons. So we've used 8, 16, 24, 32, and everything has 8. So make sure that you do go through those steps, refresh yourself. Just that repetition and practice is really good. It's a fairly simple skill, and it's probably a skill that you remember somewhat from previous classes, but it's really easy to slip up and to make mistakes in terms of single versus double bonds or forget lone pairs if you haven't refreshed yourself. So down here, we've got the ammonium ion. Some things when we have a polyatomic ion that are important are that we do put it in brackets with the charge on the outside. And then the other thing right here is that hydrogens will never have a dot of any sort. They won't have 1 dot, they won't have 2 dots, they won't have a double bond. An electron, or excuse me, a hydrogen atom becomes full with 2 electrons. So a single bond is not only all it needs, it's all that it can hold. The other thing with a polyatomic ion, remember that a positive charge means we have fewer electrons than we would as we add these up. So 5 plus 4 would be 9, but because of that positive 1 has been removed, then we only have 8. Up here on the hypochlorite ion, 7 plus 6 would be 13. That'd be an odd number, but that electron right there, or the negative charge, gets us up to 14, 6, 6, and 2. Everything has 8. Here is our first example with a double bond, but when going through the process, you start single bond, single bond, single bond, and then you'd put 6 dots on oxygen. That would fill the octet for hydrogen, for hydrogen, for oxygen, but carbon would have only had 1, 2, 3 before that was a double bond. 3 bonds, which would be 6 electrons. So when the central atom doesn't have a full octet and you don't have any more dots that you can add to your central atom, that's when you move electrons from an outer atom in, and we'll see lots of different rules and expectations as to how we can predict which one would do that.